the current construction paradigms in the building industries are still very much rooted in an industrial age. So the invention of the fabrication plant, or also inventions of the invention of the high-rise, that's almost 150 years back, and the whole industry, like opposed to, for example, the car industry, the construction industry has not changed very much, really. There were several attempts. Again, on the left side, you see how the car production industry has improved. On the right side, you see examples from Japan from the 90s, where there were several attempts of automation in the building industry, but they were not really successful. The speed was a little bit, it increased compared to conventional construction methods, but it was still very much the same if you compare it to the effort which ran into the whole thing. And one of the most apparent issues was that these attempts were very much trying to bring the concept from other production industries into the building, meaning they were creating a closed environment, which you see on the very right side, to kind of shelter this whole construction progress, and that made it very unflexible. So you could only produce one very specific typology with one kind of large machinery. There are actually two examples here in Singapore. One is the HDB hub in Toa Payoh, as far as I know, which was constructed with such a typology, with such a technology. So what we're looking at different construction machines. Again, on the left side, you see a conventional construction machine. It's lifting very large and heavy pieces. On the right side is somehow an illustration of what we try to perceive for the future of construction. Now, about 7 to 8 years ago, our team has implemented this robotic arm into an architectural laboratory. And it was by doing that, it was actually the first team worldwide to start looking at robotic technologies and how to make use of them in an architectural and designer environment. What it really means for us is the following thing. If you think about how buildings are constructed, we like to take the brick wall as one of the examples for several reasons. One is that the brick is one of the oldest building components that is available, and another reason is for how you can handle it. You can handle it manually, but you can also test how to handle it with a robot. So on the left side, you see a student several years ago trying to figure out what possible configurations you could build with bricks, actually. And now, in order to control a robot, of course, you need to translate this logic into a code, into a little programming code, and then you can program the robot. And the interesting thing about the robot is when you look at this brick wall as one of the key examples, every one of us is able to imagine how a normal brick wall looks like. And you could probably imagine as well that it's possible to build something like this by hand. But if you think about what it implies, you start realizing how difficult it really would be, and that it would not be feasible at all. The robot, on the other hand, does not really mind to do the same procedure repetitively over, but it can actually change that like from step to step, and that's why you can position each brick in slightly different rotations.